All right, guys. So today's video is on our notes 9-3, day 3. So this is kind of a review of everything we've been talking about with simplifying radicals. So all you need out today are your notes. If you have not emailed me that worksheet from yesterday, please do so. You should be able to copy and paste it or just do it in a separate document and ink and just email it to me. I'm fine with that as well. Show your work, do your best, circle your answers so I can see what's up. Great. Today's kind of a review, putting everything together. So a radical is considered simplified if and only if there are no perfect squares in the radical sign, if there are no fractions in the radical sign, and there are no radicals in the denominator of a fraction. So let's start with number 1. The square root of 60 times the square root of 28. We talked about how there are multiple ways you can solve this problem. For me, I'm going to multiply the square root of 60 times the square root of 28 first. When you do that, you get 1,680. Two numbers that can come out of that are going to be the square root of 10. I like the buddy pair, right? So I'm looking for buddies when I break this down. And the square root of 168. Square root of 10 will break to 2 and 5. 168 will break down to 8 and 21. Scroll down a little bit. Okay, square root of 8 will become 4 and 2 and 2 and 2. 21 is square root of 7 times the square root of 3. So now I'm looking for my buddy pairs. I have a group of 2's right there, or a buddy pair of 2's. I have a buddy pair of 2's again, and that looks like that's all I'm going to have. So, oh shoot, sorry. 2 times 2, don't need that radical sign. 2 times 2, because I have this buddy pair and this buddy pair, is 4. And now everything else needs to stay in the radical. 7 times 3 is 21. 21 times 5 is 105. There's my answer. All right, I'm going to try and move that this way more around. Number 2. This was stuff from yesterday. I'm going to multiply by the square root of 6 on the top and bottom because I do not want to have that square root sign in the denominator. When I do that, I'm going to get the square root of 12 over 6. 12 will break down to 3 and 4. 4 will break down to 2 and 2, so I get 2 root 3 over 6. I can simplify this to get 1 and 3, so I would get a square root of 3 over 3. Or you could also look at 2/6 right away and simplify that to 1/3. Multiply the denominator by square root 3, the numerator by square root 3. You should still get the same answer. All right. I am going to try and, oh, that's fancy, delete this real quick. So I just deleted that so we had some more room over here for this next problem. Take a look. Again, multiple ways you can solve this. When I look at this, I see these 3's are going to cancel. Remember, what's on the outside stays on the outside, inside, inside. This 2 could become a 1. This 4 could become a 2. So I get 1/2. All right, when I multiply 72 times 6, I'm going to get the square root 432. Big number. Break it down. I know, 432, I'm looking for perfect squares. You can break it down to 4 and the square root of 108. 4 will break down to 2 and 2. I'm looking for my buddy pairs. 108 will break down to 9 and 12. Square root of 9, square root of 12, square root of 9. Perfect square. We get 3 and 3. 12 will be 4 and 3. 4 becomes square root 2 times square root 2. I'm looking for buddy pairs. So here's one group of 2's times maybe a group of 3. We have a group of 2. 2 times 3 is 12. 12 times 2. Whoa. 2 times 3 is 6. 6 times 2 is 12. Can't forget about this 1/2 out front. So 1/2 of 12 is 6. All right. We get 6 square root of 3. Mr. Dorsky, where's that square root of 3 coming from? We have this guy right here. All right. Remember when we were talking in chapter 7, I talked to you guys about how sometimes it might be beneficial to circle your GCF out front. Same thing here. If you have something out front, you can't forget to multiply that into your final answers. That's where that 6 came from. If you got 12 root 3, you forgot to multiply by 1/2. Right? Let's try number 4. Number 4, outside stay with outside, inside with inside. Again, with this, there are multiple ways you can go through it and solve. When I look at this, I have a -6 on the outside. All right, I know that this could be 120 over 1, right? And I can eliminate the 6 and I can kind of simplify a little bit. So when I do that, I'm going to break this down. 120 times 25 divided by 6. I'm going to break this down to 6 root 20 times the square root of 25 because I know that 25 is a perfect square. So I don't really want to lose that. When I do that, I'm going to break this down farther. 20 is going to become square root 4, square root 5, 2 and 2, which is just what I want. 25, we already know that's 5 and 5, right? So we're going to have a group of 2's that go and join that -6. I'm also going to have a group of 5 that joins that -6. And I have a leftover square root of 5. So for this one, 5 times 2 is 10. 10 times -6, I'm going to get -60 square root 5 is my answer for that. All right, I want you guys to do number 5. Think about the conjugate. I'm going to go ahead and do number 6. So 6, conjugate stuff. Conjugate is going to be 10 minus the square root of 2. 10 minus the square root of 2. Multiply that out, distribute up top. We get 8 times 10 is 80. 8 times -√2 is going to be -8 root 2. Down below, FOIL, 10 times 10, 100. 10 times -2, -10 root 2, positive 10 root 2, and then minus square root 4. I see a lot I can simplify. These middle guys cancel. Up top, I'm going to leave it as 80 minus 8 root 2. Down below, we get 100 minus 2, which is 98. I still see things that can be simplified. I'm going to divide these guys by 2. 80 divided by 2 gives me 40 minus 4 root 2 over 98 divided by 2 is 49. All right, this stuff's hard. Try it. Make sure your conjugate for number 5 is 1 plus the square root of 5. Distribute up top, FOIL down below. Circle your answer. All right, I'm going to have you guys send me a picture of number 5. I'm going to have you guys do 7. I'm going to have you guys do 8. Again, you're looking for buddy pairs in there. And I'm going to hop in on 9. 9, take a look at it. You can already simplify some of this. I'm going to divide the top and bottom by 2. So I'm going to get 8 over 5. These x's eliminate with my exponent property. Y to the 12th minus y to the 4th is going to give me y to the 8th up top. This is all still in the square root bracket. When I go in, I'm going to multiply by square root 5 on top and bottom to get rid of this radical sign in the denominator. So now I have 8y to the 8th square root 5. Oops, sorry. I'm going to have y to the 4th because 2 buddy pairs can come out of this guy times the square root of 8 times the square root of 5 over 5. All right, I get y to the 4th square root 40 over 5. I can simplify that down a little bit. Sorry, I'm running out of room. I know this guy can become 4 and 10, and that 4 becomes a 2. So 2 goes out. So I have 2y to the 4th root 10 over 5. All right, we're going to keep working on this, but as long as you're getting into the habit of seeing what can come out, you're good. 10 we're going to skip. Let's go ahead and try 11. So 11, I'm going to do it down here. Actually. All right, 11.